Sketch a graph of y is equal to x cubed plus 2x squared minus 15x. Well, this one, we haven't got the factorised form, but this is actually very, very easy to factorise when we just don't have plus a number on the end. When we have plus a constant on the end, we will look at that when we do what's known as the remainder theorem and the factor theorem. Okay, so first what we need to do is factorise the right-hand side of this. So we've got y is equal to x cubed plus 2x squared minus 15x. If we look at all three terms here, x is a common factor, and I'll be left with x squared from there, plus 2x from here, and then a minus 15 from here. Right, now we can look at this is just a simple quadratic to factorise. You can do products on factors, but it actually factorises quite simple. So we've got x bracket x plus something, x plus something. Factors of 15 are 1 and 15 and 3 and 5. And 3 and 5 we can get 2. So let's put those in 3 and 5. And 1 plus 2. So this one has to be plus. And this one has to be negative. Now I can draw a set of axes. So drawing a set of axes, make sure you draw them with a ruler, label them x and y at each end. Then we go through x-axis, y is equal to 0, so that means that x bracket x minus 3, x plus 5 is equal to 0, which means that x is equal to 0, x is equal to 3, and x is equal to minus 5. We can plot those points on our graph. X is 0 is there, x is equal to 3 is there, and x is equal to minus 5 is there. Now we don't really need to do the y-axis because the y-axis it does cross at 0, but we can just confirm that's true. Y-axis x is equal to 0, which means 0 times 0 minus 3, 0 plus 5, and that's going to give me 0 times minus 3 times 5. 0 times anything is equal to 0, so it confirms that point there. Now the most dominant part of y is equal to x cubed plus 2x squared minus 15x is obviously the x cubed. We just look at that. So when x goes very, very negatively large, or very, very, very small, we could say, so we're going down this end of the curve, if you cube a negative number, it is also negative. So this will also be y will go towards minus infinity. Now if you don't like infinity, then try something like minus 10 or minus 100, and obviously if you cube that it will be negative but larger. And the same with, so the graph will start over here, and when you do x goes to plus infinity, if you don't like plus infinity, look like 10 or 100, and you cube that, it will remain positive. So the graph will finish over here. So what we're saying here, from minus infinity starts over here, plus infinity will start over here. So the graph is going to start over here, go up, come back down again, through that point, down again, and through that point there. So we can draw our curve and label it at one end, and at this point here will be a local maximum point, which we'll find when we do calculus, and this will be a local minimum point, again, which we'll find when we do calculus. We can look at this as the GeoGebra applet, and in the GeoGebra applet I will put the link to it in the notes of this video. So we go to the GeoGebra applet. This is y is equal to x cubed, all these are at 0. So if I set b to 5, leave c where it is, and put d to 3, okay, you can see the graph that we've got, the same sort of graph that we've got, and you can practice this using for yourselves with this GeoGebra applet using the link from the notes of the video. Okay, you can see down here we've got 1 times x plus 5 times x minus 3, just in a different order, and this is what the graph would look like. There's no number on the end, so it's just plus 0. Okay, I hope you have understood this video, and I thank you very much for watching.